Here we go. Higher order derivatives are basically derivatives of derivatives. So you take the derivative for the second derivative, take it twice. For the third derivative, you take it 3 times. All right, and you could take the derivative over and over and over and over again. Typically, if you see a problem where it's like the 99th derivative, they don't really expect you to take the derivative 99 times. You're looking for a pattern, is what you're looking for there. So you guys might remember from middle school when you had to do like sequences, geometric sequences, things like that. You were looking for a pattern, so you'd expand the first couple of terms and you'd struggle with it probably, and hopefully find a pattern at some point. You'll see the patterns a lot of times turn out to be pretty similar, but that's kind of what they look for. I believe on your homework they ask for you to try to do 2 of them. I think it's like the 99th derivative and maybe one a little bit further than that. Anyway, it usually has to do with factorials in the answer and things like that. So we can work on maybe 1 or 2 of those together. So going through these notes, they're very short. Second derivative is the derivative of the derivative. The first derivative tells us if a function is increasing or decreasing. The second derivative tells us if the first derivative is increasing or decreasing. Does that make sense?
Surprises.
Okay. You will find whenever we start doing curve sketching, the second derivative talks about concavity. So basically, if you think of what concave is, like for example, this would be concave up. As we move, the derivative is actually increasing there. So the second derivative would talk to concavity. In physics, the first derivative of the position function or the displacement function is velocity. The derivative of the velocity function is acceleration. Okay, so the second derivative has some pretty practical applications. All right, this looks like the second derivative is either going to be f with a double prime there, x, or y double prime, or you will see it as d squared y dx squared, which is basically, you remember when we were talking about what this means? This is a verb. It means take the derivative. This would be take the derivative of the derivative already, right? And that's where, so d dy turns into d squared y. dx is dx squared. And that's where that comes from. It's just the derivative of the derivative. All right, so let's find the first and second derivative of these 2 examples. So first derivative, y prime, and then where does it go? 2x plus 3. All right, second derivative is y prime prime, y double prime is equal to 2.
What does that tell you, though?
It tells you that the second derivative is positive, and it's 2, so you could tell this is the graph is concave up. If this were the position function, the velocity would be 2x plus 3, the acceleration would be 2. And there's other applications for that. All right, the next one, what would the third derivative be? 0. Okay. The next one is implicit. So this is 2x plus 2y dy dx equals 0. So there's part of the first derivative. 2y dy dx is equal to negative 2x dy dx turns into negative 2x over 2y, which is what? Negative x over y. second derivative. How do I do that? What's the derivative? What's the derivative of this side right here? That's what we're doing, right? So this is going to be the derivative of negative x over y dx. Okay, so this turns into d squared y over dx squared, which is just the second derivative. This side I'm going to do low d high minus high d low. What's the derivative of the low? It's 1 times what? dy dx. Over low squared, which is negative y plus x dy dx over y squared. Does anybody see a problem with that?
The x and the dy dx.
I've got this slope in this derivative. The first derivative is a part of the second derivative. So what do I do?
Hey, looky here.
I'm going to take that and plug it in. So and just to clean that up a little bit, that's negative y plus negative x squared over y squared. Common denominator makes this negative y squared minus x squared over y squared. Go with me? So that's, I'm going to factor out a negative 1. That's y squared plus x squared over y cubed. And that's your second derivative. All right, any questions on second derivatives?
Need a little practice.
Need a little practice. Okay. All right, you can expect a quiz tomorrow over implicit derivatives.